We have a really big 2 days ahead of us as we finish the last 3 and 4 days of Module 10, Lesson 4, where we're continuing our study of mean, median, mode, and range, also known as measures of central tendency and variability. Now we're going to start off with a activity where we're going to create a foldable. You're going to have a sheet of paper. On one side is going to look like this, on the other side it's going to look like that. You're going to cut your sheet of paper into a square just like I have mine, and then you're going to cut halfway up on each of the name sides. Where there's mean, I cut halfway up on the mean. Median, I'm going to cut halfway up on the median. And mode, between mode and range, I'm going to cut halfway up on it as well. Then I can take and fold each of these over, and that's going to create a foldable that's going to be a quick reference for me since I can't seem to remember what the mean, median, and mode are. This will help me as a kind of a clue to study for those things for my test. Now, of course, you can't have this on the test. By the time you get to the test, you're going to expect to have it memorized. But now take a look at this. So I've got the first item up there is a mean. I open that and it says the average number in a set of data and gives you an example of how to do it. The next one is the median, the middle number of the set of data, and gives you an example of how to do it. The next one is the mode, the number that occurs most frequently in a set of data, and gives you information on it. And finally, the range, being the difference between the greatest and least data values in the set, and gives you an example of how to do it. So this might come in handy to you as you dive into all that we have ahead of us, and we have a lot ahead of us. Now from here, we're going to jump back with Samantha, who we were working with yesterday. Remember, Samantha did all that work involving lipstick, and now she's a little bit confused. She decides to buy the brand of lipstick that she originally chose when she used the median as her method for selection, but she's confused about why the median and the mean prices are different. So she decided to seek out her older sister Linda to help her understand the difference. Now, since relatives often stay with a family for short periods, Linda decided to use the ages of the family members staying at the house at various times to help her sister understand why the values of the mean and the median may be different. And she's going to set up a variety of scenarios to do this. It says the following scenarios are given in chronological order. Whoops, hold on. Alright, sorry about that. I had to get some announcements out. It said each additional part of the question is based on the information from all of the previous parts. So you have to work these in order. If you don't work them in order, you're going to get left behind. For each of the scenarios, complete the following. 1. List the family members currently living in the house. 2. Predict how the median age and the mean age of those family members change from the previous scenario. 3. Confirm your prediction by actually calculating the median and the mean age of the family members currently living in the house. And then 4. Explain why the mean and the median changes or stays the same. Now, our very first scenario deals with Samantha's family. Dealing with Samantha's family involves Rashid, her brother, Mom, who's 42, Dad, who's 44, Sister Linda, who's 17, and Samantha herself, who is 11. And we're going to have to take and calculate the mean and the median of both of those. So that's your first job. Go ahead and pause the video and work on that. So when I calculated the mean, I added up the ages of each of the family members and got 128. Then I divided that by the 5 family members and found that the average age of the family members was 25.6 years of age. Then I did I wrote that wrong. I said mean, and it should be the median. So right here, I'm going to change that to be median, where I took and put the ages in order from least to greatest and found out that the middle value, Sister Linda, was 17 years old. Now, there's a pretty big difference between 17 years and 25.6 years. That difference is being caused by the fact that Mom and Dad are so much older than everybody else. Not saying they're old, I'm a lot older than them, but they're a lot older than the kids are, and that skewed that data to the right, making it a little bit higher. Now in scenario 2, Dad leaves town for a month and he's replaced by Grandpa James, who is 68 years old. He's going to move in and help. You still have 5 family members, but we need to take and figure out what is going to happen. So we're taking someone who's 44 and replacing him with someone who's 68. What do you think that's going to do to the mean or the average? I think it's going to make it go up. Of course, you're going to need to pause the video and find out how that affects both the mean and the median data values of this set. Go ahead and do that right now. So how did that end up affecting our data? Well, you can see when we took Dad out of the picture and added Grandpa, who was 68 years age, that meant the mean or average increased to 30.4. But the median didn't change at all. Sister, I think it was Linda, is still going to be the middle-aged child, so she's going to still be the one in the middle. So my prediction held true. I am back and a little hot and sweaty because I had to take a break to run with the Cross Trainers Club, but here we are again. Now we have some changes that are taking place. So Dad came home, Grandpa James leaves, and then Mom's sister, Liz, takes Samantha away to camp, but leaves the 1-year-old daughter, Alyssa. So we got some serious changes we're going to do. So let's take and kind of walk through these changes together. Man, I am so sweaty. All right, so we're going to take and paste in what we had from before. And I'm going to, whoops, hold on. All right, there we got it. Now, we're going to take and first off, get rid of Grandpa and replace Grandpa with Dad. So that means I can take out that. All of this math is going to change again, and I can take out this. And Dad, as you recall, was 44. So I'm going to take and let's put a different color in here just to make sure we're all understanding this difference. Here's Dad at 44. But we also took somebody else away. We took away Samantha and was left with a 1-year-old child. So I'm thinking my overall median thing is going to change. So let's see how old Samantha was. We can go back to our previous page, and Samantha was 11. All right, so our star student is gone. So we're going to take away the 11-year-old and add a 1-year-old. So right here, the 11-year-old's gone. And right there, the 11-year-old's gone, and we're going to replace those two 11-year-old points with a 1-year-old. Now that we have that data, first thing I'm going to note is that the median still didn't change. The median's still 17. Now, you guys pause the video and find the mean. This is what I came up with. We ended up getting a total age now of 118, and when we divided that one by 5, got hot and sweaty from that run, when we divided that one by 5, we got 23.6. So now our mean age is less than our very first mean age. The only information that's different from the beginning, though, was we took away 11-year-old Samantha and replaced her with 1-year-old Alyssa. So now that brought the mean down even more, closer to the age of the children, but it's still pretty high up from the children. And the reason it's still pretty high up is that Mom and Dad are still pretty old compared to everybody else. All right, let's take the next one. So I'm going to take and copy up this set, and we're going to see what we have next. Samantha comes home from camp and Alyssa leaves. So let's work that out there. So I'm going to take and we're going to drop this in, unlock it, and we're going to delete Alyssa. So the baby's gone, and we're going to be replaced with Samantha. So now we're going to take and let's just put an 11-year-old here and 11-year-old here. And then Linda graduated from high school and leaves for college. So Linda's the 17-year-old. She's kind of graduating pretty young. So we're going to take and delete Linda from existence here and here. We also need to get rid of all of that. And let's pick a different color here for Linda's replacement. So Linda was 17, and she was replaced with Kevin, who is 8 years old. And Kevin is now going to totally screw up our median. So we're going to put an 8 years old here, and I'm going to have to completely redo this. Now I'm going to have an 8-year-old. I think I can write that neater than that. An 8-year-old, an 11-year-old, whoops, not an equal sign, a 14-year-old, a 42-year-old, and a 44-year-old. So we have a whole new set of data that we're working here for the median, and that means that my median is going to be what this time? The median is now 14. Now it's going to be time for you to pause the video, and you're going to take and work scenarios 5, 6, and 7. Go ahead and do that now. So, for scenario 5, Grandpa Charlie, who's 94 years old, needed a place to live with a family. So he came to live at Samantha's house. Meanwhile, Mom went away on a business trip. That meant that 42-year-old Mom was replaced with 94-year-old Grandpa. That raised the mean a lot. Grandpa was what we call a definite outlier in the age category, took it all the way up to 34.2. But what did it do to the median? Absolutely nothing. The median was 14 before. The median is still 14 now, being the middle value. For scenario 6, twins, cousins, I guess it was just 5 and 6 you should have done. Twin cousins, Amanda and Keisha, who are 12, need a place to live. Mom comes home from a trip. Kevin and Grandpa, Charlie, decide there's too many girls, so they leave. Did you catch what actually transpired there? You had 3 people come and 2 people leave. Twin cousins, 12 years old. You had 2 12-year-olds come in, and because of that, that had an impact on how I worked the problem. We're going to take, first off, and I just want to talk about, it's not going to let me do what I want to do there, the median. The median, we now have 2 middle numbers going on, and I'm going to take my 2 middle numbers, which are right here, and I'm going to average them. To do that, I'm going to do 12 plus 14 divided by 2. That's, of course, going to equal to 26 divided by 2, or 13. So 13 is the new median number. Meanwhile, on the mean or average, we added up all 6 of them, divided by 6, and that gave us the lowest mean we've had so far of 22.5, because the kids are really starting to outnumber the adults here. Now, from here, you are going to create your own scenario in which Linda is going to be the median age and the mean age changes. Will the mean increase or will the mean decrease in your scenario? From there, you've got more work you're going to do. You're going to answer question B. You're going to keep working through question 5 here. We got lots going on here. This is a lot of on your own and with your partner works. You can go all the way through the next page, to right there. And then we're going to start talking about something evil called mean absolute deviation. Guess what? We're not going to talk about it, because that is now a 7th grade standard. You need to thank the Lord above or whatever else, because there is you don't have to do this. This is brutal work. So we're going to stop at, I believe that's 5D is going to be the last thing you're going to do right here. So at this point, I'm cutting the video off. You guys have yourselves a great day. Get busy working on it, and I look forward to seeing you in class.